The idea of rationalizing a denominator means get the square roots out of the bottom. And so that usually means doing something to both top and bottom so that this radical goes away. And what we're going to do is going to have to leave the value of this unchanged. So the first thing I want you guys to know is when you're rationalizing denominators, you're going to be taking some kind of something and multiplying it by the top and the bottom. And whatever you put in the bottom should make this go away. So this is the one you might be used to. And the idea here is just I'll put a root 5 here, and I'll also multiply the top by that as well. And the reason why that's going to work out for us is because if I have root 5 times root 5 times root 5 is the same thing, of course, as root 5 squared. And everyone knows that if you square something that was square rooted, the square and the square root cancel, you just get 5 back again. So, and you also probably remember maybe that when you multiply fractions, top by top is the new top, bottom by bottom is the new bottom. So the bottom here is going to become root 5 times root 5, which is just plain old 5, square root cancels. And the top's going to become 7 times the square root of 5. And I'm done. Now the thing is, this answer doesn't look better. In fact, this answer probably looks worse. But there's reasons why we do this type of stuff. It has to do with how well computers can do the two operations and how accurate we want our answers to be. So there's a reason to do this. Just know that it's probably going to make your answer look worse. But I know I did it right because the square root's out of the bottom. And that's the goal here. Get that square root out of the bottom. And we did it. If you ever are wondering if you did this correctly or not, you can always get out your little Casio handheld calculator. And on it you can do 7 divided by square root of 5 and see what that gross decimal is, because it'll be a gross decimal. And then, kind of memorize that decimal a little bit. And then do 7 times root 5, press equals, divide that by 5, and you'll see the same gross decimal, so you know that they're equivalent. So this next example is pretty different though, so definitely check out that video, and I'll see you guys there. Bye.